Okay, welcome back to the crowd coding live session of flagship game. Today we are trying to place the flags in the grid, and we are doing it not alone but together with friends from Cyprus. So please, Antonis, who is the Code Week ambassador from Cyprus, introduce your class, and then we are ready to start. Thank you very much. Enjoy. Bye. Okay, so we are ready to start now. This is the mockup that we want to reproduce. It is put it in front of the main window in which we have the focus, thanks to an application developed by one of my students, who is called Lawrence Klopfenstein. The application is on top replica. I have also an emulator where I'm showing the layout that we designed so far, and as you can see, we need to place flags in it. The layout is the one that is represented also in this, which is the designer of App Inventor. As you can see, they do not look very similar because all the interface elements that I added in App Inventor were then slightly changed and adapted using code. So, for instance, the size of this element, which is the one in which the grid will be designed, is completely different because it was completely resized using code, and even the background color is different. So let's look at this element. This is a canvas. You can find it here. And this canvas was called grid. This is the element that can allocate all the flags. And the flags, each one of the flag will be an image sprite. So I need to add to the interface as many image sprites as the flags that I want to place. So I need 16 image sprites. To do so, I have to drag them and drop 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And here we are. Right now we have all the sprites that we need, but we should change each of them in many different ways, because we should associate an image with each sprite in order to make it contain a flag, and we should decide a position for each sprite. If we did it in the interface, we had two main problems. The first one is that the look and feel of this interface is not exactly the one that we want to achieve, because all the layout was fine-tuned using code. So it would be very hard to decide a position for a sprite just by moving it around in this canvas. The second issue is that we could do it just statically, not dynamically. This means that we could decide once and for all which flag to place in this position, but we want our game to take flags randomly and to propose a different grid each time we launch the application or we restart the game. So we need to write code to this purpose. So let's go to the block design. And in the block design, we find some procedures which are these three. Prepare screen is the one that we developed so far to define the layout. if I expand this block, I can find here all the code that we needed to write to resize and change the background color of all the interface elements. So I collapse it again because right now we have to focus on this. And also notice that I added, with respect to the previous time we met, I added another variable which is called countries, which is a list of the acronyms of all the 38 code week countries. Those acronyms here correspond to the name of the flags, or better, to the name of the PNG files containing the flags. And this will be used in our procedure to automatically associate flags with image sprites. So this is the function that we need to implement, and what is interesting here is that instead of defining each sprite, we will try to write a general code segment containing a loop, or better, two nested loops, in order to do it automatically for all the sprites and all the flags. So both the position and the flag to be represented will be defined algorithmically, not statically and not manually. Okay, and to this purpose, I need to create a list of sprites in order to be able not to name them one at a time, but to refer to all of them as a verb. So let's go to the list, and I take this one, which is add item to the list, and I create a variable to represent the list, which is a global variable. This global variable will be called cells, because what I want to say is that from my point of view, the 16 sprites should take positions in the grid as if they were cells of the grid, and they will be associated with flags, which are the flags that I want to place in that particular cell of the grid. So let's say that for our purposes, sprites in this particular application will represent grid cells, so that we will be able then to decide which is the position taken by each cell, and then to put an image, which is a flag, on each cell. So in order for this variable to represent a list, I initialize it in this way. So I say that cells initially is an empty list. Then here I get the global variable cells, which is the list to which I want to add items. And in order to add all the items here, I do this. Oh, sorry, I did it in the wrong place. Here. I keep adding elements because I need 16 of them. Those are 4, 5, 6, 8, 7, 8, 9, 10, 11, 12, 13, 14, oops, and 16. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 16. Okay, here we are. Now I can add the elements, and the elements that I want to add are these ones. First element is image sprite 1. Here it is. And then in order to add all the other elements, instead of going into each of them and find a reference to the image sprite, I can go here and copy and paste or duplicate, which is the same, the elements, and then add them in this way and associate them with a different sprite. Okay, so it is much easier. and much faster. Okay, 5, 6, 7, 8, 9, 10, 11, 12. This is quite boring, but we are doing it several times in order to avoid doing several times all the other steps, because in this way we are defining a list of sprites which will allow us later on to just refer to the list to iteratively do something for all the sprites. Then now I'm introducing something which is new, which are the local variables. So instead of defining variables outside the procedure and then use them inside, I can directly define a variable inside a procedure. And this is called local rather than global, because this variable cannot be used outside the block in which it is defined. So if I place this block here, this means that I will be able to use this variable, the name of which is k, only within this block. And I initialize it to 1. And then I define another variable, which is local as well, inside this one. Notice that this is those are two nested blocks. This means that if I work inside the inner block, I will be able to use both variables. Okay, the second variable will be cell W, which is the size of the cell, and here I will initialize it to the actual value of the size of the cell. Notice that I have other variables which are game W and game H. Game W in particular is the width of the part of the screen that we use for playing our game. So I can do something like this, which is taking the global variable, which is called the game width, and divide it by 4 in order to define the width of the cell, because I want the cell to be 1/4 of the overall size of the canvas, in order for 4 cells to accommodate on a row. Okay. Then I go into the control panel and I take this other block here, which is an iteration. In this way, I can define a variable which is called row, and I can define a starting value for this variable, a final value for this variable, and a step. What happens here is that this block and all the instructions that I will place inside this block will be executed not just once, but as many times as the times that are required for this variable to go from 0 to 3. This means that it will be executed 4 times, and at each time the row will be a local variable taking the proper value. So this means that the first time we execute it inside here, row will take value 0, then 1, then 2, then 3. That's 4 times. That is the execution of all of them. Now let me introduce another local variable here, which is called y, because it will represent the y coordinate of our grid. And the y coordinate is the vertical position of the element that belongs to this row. Since the row starts from 0, I can algorithmically compute the position of each row by doing this, which is just a very simple operation. So I take the cell W, which is the size of a cell, and notice that cells will be squares. So the width and the height are the same, and that's why I don't need to also define an height of the cell. So I take this and I multiply it by row. So the first time y will be 0, and 0 is a relative position with respect to this corner of the canvas in which the flags will be placed. The second time we execute it, row will take value 1, so cell W times row will be the size of a cell, so the position will be this. The third time will be this, and the fourth time will be this. So this means that this is the top corner of the sprite that we want to place. Okay, now we are ready to do something inside each row, and inside each row we need to span columns. So we need to add something which looks like this one, and we do it this way. We call it col, which stands for columns, and again it goes from 0 to 3, one by one. And then we initialize another local variable, which is x, the horizontal position. We can duplicate this piece of code and to change it to column. Notice that here I have all the variables available because those are all nested one in each other. So the inner one has all the previous variables available. While as I go out, if I put an instruction here, I have just k and I cannot use all the other variables. Okay, now it's time for us to play with sprites, because we now have the coordinates. We have 2 nested loops which iterate to all the rows and all the columns. So this means that these inner instructions here will be executed 16 times, one for each position in the grid. And that's what we wanted. Now, I will initialize another variable, yet another, and I call it this sprite to allow me to single out one of the sprites belonging to the list, because I need to select it from the list based on its actual position. So to this purpose, I do in this way. This is the instruction that I need. Here I have to specify the list, and the list is this one, is global cells. And then I have to specify the index of the element that I want. And the element that I want is k. Why is it k? Because k initially is 1, and then within this loop, I will increment it one by one in order to span all the blocks. In order not to forget to do it later, I will put the increment of k soon. So to this purpose, I do this way: set k to the result of a sum, which is k plus, you see, I can duplicate any element which is useful at this point. So I could have taken 1 from math as a constant and rewrite it to 1, or otherwise I could have done as I'm doing, which is just try to recycle some piece of code that I already wrote. So this is the increment of k, so that at next iteration k will take value 2, so that I will select the second sprite instead of the first one. Great. Now we can add some code here to place the sprites and to associate flags with them. This is something which is done either by looking at each sprite and by taking its specific instructions, but this is not what we want to do, because we need to have a sprite as something which is parameterized. So this sprite is a variable, is not a static reference to a given sprite. So in order to do so, there are other components here which are called any component. And among any components, I find all the component types that I added to my interface. And in particular, this is any image sprite, which is what I need. And I can take set image sprite enabled, which enables the sprite, which otherwise could be even disabled or possibly made not visible. And then here I will add the component which is represented by this variable called this sprite. And I have to set it to true in order to enable it. So now the sprite is enabled. Then I can duplicate this and add another property to this specific sprite, which is the visibility. So in this way, I'm making it visible. And then, most important probably, I have to associate a picture with it. Notice that I'm reusing code even if I need to do something different, because then I can slightly modify it. So in this way, I can associate a picture with this sprite. So this is not a picture, it is not a true or false value, it's not a logic value, but rather I have to specify a picture. To specify a picture, let me go back to the designer, or just go down here to, here, to see that pictures have names which correspond to the 2 letters acronym of the country, .png. So as I mentioned, I have a list called countries, which is a global variable that contains all the acronyms. So what I can do is just pick one of them from the list. So the list is called countries. So let me go here and take it. But this is a list, so I cannot just use it directly. So I need to do something like that. First of all, I need to pick the proper element from this list. So this is select element, and then I use a variable k to get each time a different element. And also notice that at this point, I need also, you see that there is this alarm here because I'm using K outside the place in which it is defined. If I put it here, automatically it disappears. But the reason why I'm not putting it here is that this is not yet the proper name, because the proper name contains also .png. So to this purpose, I go into the text and the panel where I take join, and I join the extension, which is .png, the name of the file. Then I keep specifying properties, like, for instance, the width of the sprite, which could be the cell width, but I don't want the sprite to cover the entire size of the cell, because I want some margin, to leave some margin between a cell and the other. So I do it in this way. I take math, and from here I take a variable which is cell width, and a constant which represents the number of pixels, for instance 6, that will be left at both sides for as a margin between the flags. Then I do the same for the height. Here it is. And then I decide the position of the sprite within the cell. And to this purpose, I use X and Y, but I have also to add some misplacement from that, because I want the flag to be centered with respect to the cell according to the margins that I left. So let me go here and specify this. So set image sprite X, and here I take variable X, not minus, sorry, but plus 3 in this case. Three is a half of the reduction in size that I introduced here. So this means that I will leave 3 pixels to the left and 3 pixels to the right of each flag. Okay, let me do the same for the Y axis, for the vertical position. And this is more or less it. Let me think a little bit if there is something missing. Okay, well, I noticed that there is a logic mistake here, because in order not to forget to increment K, I incremented it soon, but this has to be done after the execution of this piece of code. Otherwise, K will take a value here and a different value in the rest of the code, which is the code working on the same sprite. So I need to take it out from here and to place it at the bottom of this code segment. Okay, I think that now we are ready to test the functionalities that we introduced. I'm pretty curious to see if they work at the first attempt. This is not sure. So I'm building the application and saving it as an APK file to my computer, to my download folder, in order to be able then to drag it and drop on the emulator. Okay, so app inventory is building the package. If you have your Android devices in hands, you can go into the build command, or well, you can do in many different ways. You can even use the companion app in order to see the changes as soon as you make it. But otherwise, you can build the application on the server and then ask the server to generate a QR code in order to be able to capture the QR code with your mobile and to automatically download and install the application to test it directly, not just by using an emulator. The reason why I'm using an emulator is that otherwise I cannot show the effect on the shared screen. Okay, let's wait for the package to be downloaded. Here it is. Suspense. Ta-da! Yay! It worked. Wow. Pretty proud of it. It is not usual that something works the first attempt, so I'm happy to see that it worked. Notice that this is just something which tells us that we have placed flags in the right positions and that we have a way of placing flags automatically. But we need to add some more code in order to make them random, because right now they are placed exactly in the order in which they appear in the list, which is a static list, which is this one. Okay, so you find Austria at the first position and so on. So as you can see, they take these positions here. If I go back and play the game again, I find the flags exactly in the same position. Not only the positions are the same, but even the flags are always the same. So only the first 16 flags out of the 38 code weak countries are used in this version. So in the next coding session, we will see how to add some random effect and then how to activate the flags in order to play with it. So thank you very much for attending this live coding session, and do not forget to add your name to the list of contributors. To do so, you can go to flagshipgame.eu/join, where you can find a form that can be completed either by each individual or by a teacher, an instructor, a facilitator, in order to register an entire group of people, the names of which can be placed here. Okay, thank you very much. I hope to see you again at the next live coding session and to get your contributions to this game. Thank you. Bye-bye.